Okay, so yesterday we learned the triangle inequality, correct? Okay, so how would I know if these three sides would make a triangle? What would I have to do? Okay, so I would add the two smaller numbers together, and then I'm going to compare it to 19. And as long as it's greater than, then I could say, yes, it makes a triangle. If it's less than, then I say no. So right here, I have 23 greater than 19. So yes, this makes a triangle, right? So now I come over here and I'm going to look at 11 and 8, right? What's 11 plus 8? 19. Is that greater than 12? Yes, so this makes a triangle. Over here, I have 11 and 6. I'm going to add those two together, right? And then I'm going to see if it's greater than 18. Is 17 greater than 18? This is a no. That didn't work, so we'd say no. That's right. We say no. Okay. So how do I find the range? Remember, when you're finding the range, you want to set it up with it looking like this. This is the hardest part about this part of the lesson, is setting it up. You want X to be in between two numbers. On this side, what do we do with the two numbers? You subtract. And remember, you always want a positive number here because we can't have a negative distance. So what's 8 minus 7? 1. What is 8 plus 7? 15. So it's in between 1 and 15, and that'd be the correct answer now. So I would do a less than sign, an X, a less than sign. I'm going to put a number here and a number here, right? For the first one, what do I do with 7 and 6? Subtract, yes, minus, which is 1. And then I'm going to add, which is 13. Questions? No? And then we do the same here. I'm going to do my lesson, X lesson here. 10 minus 9 is 1. 10 plus 9 is 19. And we are good, right? Okay, so find WX. So what did we learn about the mid-segment? It's half of this length here. So what's 22 divided by 2? 11. So WX is equal to 11. Over here, I'm trying to find VW, which should also be half of CE. So I would take 20 and I divide that by 2 and I get 10. So VW is equal to 10. Now, don't remind me later. Okay, what do I do though here? Because I have uh, expressions. I don't have numbers. So how would I set up the equation? Yeah, I'm going to solve for x, but I have to set it up. How am I going to set it up? I know that, yes, the 2 times this has to equal this other side here. So I do 2 times x plus 3 and set that equal to 3x. I'm going to do the distributive property. 2 times x, 2 times 3. 2x plus 6 is equal to 3x. I'm going to subtract 2x on both sides because I want to get variables on one side, constant on the other. So I get 6 is equal to x. Am I done? No, because it asked for AB. If it asks for AB, I have to substitute that 6 in. So AB was x plus 3, so I do 6 plus 3, which is 9. So AB is equal to 9, which makes sense because what's 3 times 6? 18, and 9 is half of 18, so all is right with the world. It all worked, right? Okay, so we just set this one up the same way, and it's asking for AB again. I'm going to multiply 2 times x plus 2 equals 3x minus 2. 2 times x is 2x. 2 times 2 is 4. 3x minus 2. Now, I'm going to get variables to one side, constants to the other. A lot of you mess these up. And I do have your tests. I'll go ahead and pass those out in a minute here. You mess these up because sometimes you bring everything to the same side. Don't do that. You want variables to one side, constants to the other. I like keeping my variables positive, so I do this. Minus 2x minus 2x. That cancels. I get 4 is equal to x minus 2. I add 2 to each side. X is equal to 6. And voila, I'm done. No, I'm not done. Why am I not done? Because it wants AB. It doesn't just want X. AB is X plus 2. So AB would equal 6 plus 2, which is equal to 8. Now I'm done, right? Okay. I am going to give you a new lesson today, and then I will hand out your homework assignment, which will cover a little bit more practice on yesterday's material after our test that we went over, and then we'll be covering this new material, okay? You may get out a little early today. I think it's a short day planned. I don't know if I should have done that. Well, oh, no, we have some constructions we didn't get to. So don't get too excited because then I can teach you those constructions we didn't get to from before. Okay, let me go ahead and file. And we're going to print to PDF so I can write on this thing. So does everybody have their notes that I handed out yesterday? And you want to go to the packet part that says triangles and congruency statements. So today you are going to learn about triangles. We already talked about isosceles triangles and equilateral triangles. We did that yesterday, right? Something new, though, is the triangle sum theorem, the exterior angle theorem, and the base angle theorem. You are going to be able to classify triangles and say if they are congruent or not, and write the correct congruency statement. You will be able to find missing angles in triangles. I'm going to skip this. Oh, we have plenty of time. Okay, I'm going to pass out some scratch paper, and I want you to draw a big triangle and then use the protractor to measure each of the angles and see what happens, okay? So, let me get some scratch paper here and draw a nice big triangle. A large triangle. And then measure each of the angles. And then measure each of the sideways. And use straight edge. Thank you. And there's some writing on the back, but just ignore that. We're using it as scratch paper. So draw a nice big triangle. Any triangle you want. Use a straight edge though, so you have nice angles to measure. And then we will measure with the protractor on the bottom of the geometry template. Yeah, just a triangle. Talked about these classifications yesterday after the test, right? We have equilateral triangle. Equilateral triangle, all three sides are the same. It turns out, though, that all three angles have to be the same also. Well, if they have to be the same angle measure and they have to add up to 180, what would each angle have to be then? 60, because 180 divided by 3 is 60. So this would have to be 60, 60, 60. Right? Any questions on that? Okay, isosceles. Isosceles means that two sides are equal. And I had a couple people that made some that way, correct? And if two sides are equal, then two angles have to be equal. So these opposite sides and angles are equal. We will have a fire drill at 2:15. So hopefully y'all brought coats because we will be going outside. So angle, side, and angle. So these two would be equal. This one would not be. These have special names, so you may want to write this down because you'll hear me say this a lot. These two we call base angles. And the one that's not equal, the one that has a different size, we call that a vertex angle. And that's mainly just for isosceles triangles. So you have a vertex angle and then two base angles. The two base angles will be equal. The vertex angle would have a different measure. Any questions on that? I don't know why this is on twice. I apologize. I guess I have to re-look at these. Oh, this is the PowerPoint that got messed up. So there's some that I am going to be saying that are, hopefully yours isn't all like this too. Okay, a theorem. A theorem is a statement that has been previously proven based on established statements. So, and in geometry, vocabulary is huge. Part of my state standards is to make sure you know what a theorem is, what a postulate or axiom is. We covered this the first day of school. The triangle sum theorem. All three angles of a triangle have to add up to 180. Right? Any questions on that? We will do this construction after we finish the PowerPoint. Okay. Triangles that are congruent have congruent sides and angles. So if I say two triangles are congruent, their angles have to have the same measure, their sides have to have the same measure. Now, they could be flipped, a mirror image. They could be turned, right? And they could still be congruent, even though we flip it or turn it. In this instance, when you're looking at it, everything's in the same direction, right? But not always will that be the case. So here, we know that angle A is equal to angle D, angle C is equal to angle F, and angle B is equal to angle E. We also know CB is equal to FE. AC is equal to DF, and AB is equal to DE. Do you see that? If you need to be on your phone, you need to go out in the hallway, please. Please, please, please. Daisy? Okay. What is the correct congruency statement? So here, it's asking you these congruency statements, and when we get to similarity, those statements mean something. You have to write them correctly. To write them correctly, the angle measures have to be in the same positions that are equal. So look here. Let's look at A. Is angle T the same as angle H? These markings mean something. Angle T has a single mark, and angle T is in both of these, right? But do you see here how they have angle T in the second position instead of it in the first position like here? Because that order is out of order, this is not the correct congruency statement. Okay, let's look at B. T and T. T's are correct, right? Let's look at our U's. This U has a triple mark. See, 1, 2, 3. What about H? That has a 2-tick mark, right? Those aren't equal. So I'm going to cross that out. They have to have the same markings. Let's look at V and H. Is V, oh, here we go. V is a 2 mark. H is a 2 mark. U is a 3 mark. I is a 3 mark. This one is correct. This would be the correct congruency statement. Does that make sense? So if I ask you to write a congruency statement and you have your angles out of order, it's not going to be equal. I mean, it'll be considered wrong. Okay, next one. You all try and do number 2. If you have a question, raise your hand. So what did you get for number 2? B? D. Oh, D. D as in dog? Yes. Woof woof. Okay. So I and I, J and M, K and L. Yes. Okay, do this one. D again? Let's see. B and D, and then C and E, and D and F. Yes. Okay, so now I want you to use the congruency statements. We don't know if this is flipped, turned, or whatever. A lot of us would immediately look at the picture and ignore the congruency statement. That's not a good plan. You want to use your congruency statement. See here how H is the last one? What's the last one over here? F. And I is the first? What's the first over here? So HI is congruent to FD. See how those congruency statements can help you out. Okay, so over here, angle MNL. MNL, that's this angle here. So M and L was right in order. So what would you write right here? Angle NMS. And NMS would be this angle over here. Does that make sense? Sure. I don't know. Let's look. A, B, and no, because B is the single mark. F is a triple mark. I can't hear you. I'm sorry. What did you say? No, because this isn't an angle. This is a full triangle. So you're going to have to check all three. Okay, we good? Yeah, because now you're talking about a full figure, not just an angle. Okay. So, I am going to show you some of this. We are going, just because it is a geometry class, so I do want to expose you to what a proof looks like. Some of you who have took geometry in your home countries probably have done formal proofs at the Excel Center. Since we are only 8-week course, we don't do formal proofs, okay? So reflexive property, though, means that it's like a reflection of a mirror. It means that the same angle is equal to itself. So if, let's say, angle A is shared in one triangle, then we know it's equal to itself. That's what reflection means. Adding and subtraction properties of equality, you have done this all during algebra. So when you solved x minus 5 equals 10, you would add 5 to both sides. That would be addition property of equality. If you had x plus 5 equals 15, you would subtract 5 on both sides to solve. That would be your subtraction property of equality. Does that make sense? Symmetric property, that just means that if 180 equals angle A plus angle B plus angle C, I can rewrite that as angle A plus angle B plus angle C equals 180. See how I just flipped those around? That's your symmetric property. Multiplication and division properties of equality, that's what you did in pre-algebra and algebra also. 2x equals 10. Your division property, you would divide by 2, right? That would be division property. Multiplication property would be the opposite. If you had x divided by 5 equals 3, you would multiply by 5 on both sides, right? Those all you've done in the past. So here is an example. Angle H is congruent to angle H. This is actually more vertical angles than a shared angle, to tell you the truth. Okay, so transitive property of congruence. Right here, I want to show you that angle 1 is congruent to angle 5. What do we call angle 1 and angle 5? We worked with that on our last test. What relationship do those have? Someone said it. Who said it? Those are corresponding angles. And those two would be congruent. An example of a proof would be, vertical angles, angle 1 has to be congruent to angle 3, right? I'm trying to, and then because of corresponding, no, we were doing alternate interiors, sorry, is what we were proving. Because angle 1 is congruent to angle 3, and angle 1 is also congruent to angle 5, you can use the transitive property. Since these two are equal to the same, to different things, these two would have to be equal to each other. That'd be like me saying, who's older in here? No one's really my age. And sometimes I get people in my, let's just say, I'm going to point and I'm just going to make this up. Let's say Thu is the same age as Daisy. And Thu is the same age as Par. What do you know about the ages of Daisy and Par? Wouldn't they have to be the same? Yeah, they'd have to be the same. If Thu's age, let's say Thu is 25. How old are you, Thu? 28. I made you a little younger. I wish somebody would do that to me. Okay, so Thu is 28. Let's say that these two are also 28. If I said Thu is the same age as Daisy and Thu is the same age as Par, then Daisy and Par would be the same age. That's the transitive property. Okay? Those are I threw that in there just for you to get a feel for what proofs are. We won't do proofs in here, but I think you needed to see one before you left a geometry class. Okay. This you will use. Exterior angle theorem. Angle 1 is an exterior angle. So we have a triangle, and we extend a side. This is called the exterior angle right here. It turns out, and I could prove this to you, and maybe the next slide does, that why this actually works. But how you would solve these then is you would just add 2 and 3 together and set equal to 1. If I had angle 1 and angle 3, and I wanted to find angle 2, then you would subtract, right? Okay. Oh, yep, here's the proof. So here's the actual proof of the exterior angle theorem. Like I said, we won't be tested on these, but for some of you who are going to college, you probably should take time to look this over and understand it. If you're not going to college, don't worry about it. You do have to understand, though, that we'll be doing some of the math, though. Okay, base angle. We already talked about base angles. That if AB is congruent to BC, then these two angles would be the same, right? Okay, so use your knowledge about triangles to find these missing angles. So I don't have any side lengths. What do I know about all three of these angles, though? What should they always add up to be? 180. So to do this, you take 180 and you could just subtract the sum of these. So you do 50 plus 80 is equal to 130, right? And then you go 130, you would subtract, so that is 50. It should be this one. Sorry, I was trying to get the calculator up. Okay. Oh, there it is. No, why did you do that? No, I lost it. I thought I had it. Oh, there. No, that's not it. That's why I wouldn't do it. Okay. Sorry. Oh. Oh. So, this is the calculator you'll use for the test. Most of you know that. I just want to pull that up so that way, for some reason, there it goes. For some reason it wasn't cooperating, but now it's cooperating. Just so that way I can have that up. If you want this on your phone, you just go to TI84calc.com. And because this is the calculator you'll be given on the test. Okay. So use your knowledge about triangles to find this missing angle. So what did we do for the other one? We took the sum of these two, right? So I'm going to do 95 plus 30. And I get 125. So I add those two together equals 125. And then what do I do with 125? 180 minus 125. So 180 minus 125, and that is 55 degrees. Okay, now, these exterior angles. We said that these two added together has to equal the outside one, right? So what am I going to do with 114 and 67 to solve this? I'd have to subtract it. So you do 114 minus 67, and you get that this angle is equal to 47 degrees. 114 minus 67, 47. Okay, but of course, we'll do one more, and then we'll have some, do we have some with, that get more complicated? Yeah, some of these get more complicated. Okay. So, what time is it? Oh, I got you for a little bit more time. Okay, so we're here. So now, this one, and this one, and this one. So what am I going to do with this exterior and this interior angle to figure out the other interior angle? You just subtract. So it's just 83 minus 28. So 83 minus 28. And that would be 55 again. Now this time, they gave you the two interior angles, right? So do I subtract? No. You're going to add this time. 50 plus 86 is 136. So this one would be 50 plus 86 is 136. Boy, they gave us a lot of these on here. I need to fix this PowerPoint. What's 140 minus? You would subtract on this one, right? You get 88. And now it gets a little bit different, right? Okay, now we're working, so everybody should be on question 7. I know I went fast through all those, but we were just adding and subtracting. Okay, this is an isosceles triangle, right? So here are the two that should be equal. So do I have to do any work for angle X? No. Angle X, you should just know, is equal to 76 degrees because these two base angles were the same. Okay? Now, be careful because on the test, a lot of people, anytime they see two sides congruent, they just automatically think, oh, those two angles will be equal. But that's not always the case because when I'm talking about these two sides, remember it's this angle's 49, and then it'd be this angle that's 49 also, right? But this isn't the one they wanted. They want this vertex angle. So how do I find the vertex angle? They should always add up to 180, right? So you would do 49. I have 2 of them, which is what? 98? 49 times 2? Oh, not times 6. 98? Okay, and then you would subtract that from 180. That's how you would find that missing angle. So then 180 minus 98, which is 82 degrees. So that's what X equals. So whenever you see the two sides that are congruent, walk your finger across to the opposite. Those two are equal, right? This third one is probably a different measure. The only time all 3 would be equal is if it was 60, 60, and 60. Okay, now this one gets a little complicated because it's saying that this angle 2, because it didn't have enough room to put it in, is 8x plus 4. So it's wanting us to solve for x and then find the missing angle measure. So I need 2 answers. What angle is this one equal to? Is this one equal to the 44 or is it equal to 8x plus 4? 8x plus 4, because if you just draw those little segments like I did, these two are the ones that have to be equal. So this is also 8x plus 4. Well, now how do I set up the problem? What do you know about all the angle measures of a triangle? What should it always add up to? 180. So you do 8x plus 4 plus 8x plus 4 plus 44 is equal to what number? 180. 8x plus 8x is 4 plus 4. Oh, and I forgot the other 44. Eek! Do I have an eraser? Oh, I gotta rewrite it. Sorry. 16x plus, I forgot to add the 44. 4 plus 4 plus 44. 52. Equal to 180. Now this is a 2-step problem. You have to do 180 minus 52 divided by 16. And so then x is equal to 8. Am I done? No, it wanted to find the missing angles. So these two would be the same, but I know that the measure of angle 2 has to equal 8 times 8 plus 4. I have to substitute that back in. 8 times 8 plus 4, which is equal to what? 68 degrees. Now this one you could do it this way. Of course, you'd be making it harder on yourself if you do it this way. Or what do I know if all the sides are equal? What do all the angles have to equal? 60. So I could solve for x fairly quickly. I just do x plus 70 equals 60. So, and actually, I already know this is 60 degrees, but I have to solve for x. So x plus 70 equals 60. You subtract 70 from each side. What does x equal? Minus 10. And all of these had to equal 60 because it's an equilateral triangle. Does that make sense? Okay. Okay, for this one, use your knowledge about triangles to solve for x and then find the measure of angle A. So how would I do this problem? Three x plus 2 plus 5x plus 130 has to equal 180. I'm going to combine my like terms. My x's would be 8x plus 132 has to equal 180. I'm going to subtract 132 on both sides. 8x has to equal, what's 180 minus 32? No, 132. 180 minus 132. And that's 48. And what am I going to do now to solve? Divide by 8. So x is equal to 6. Am I done? I solved for x. That's done. But now I have to find the measure of angle A. What is 5 times 6? 30. So this is 30, right? Because you had to multiply those two. So the measure of angle A is equal to 30. Go ahead and do this one on your own. You can check your answers. Make sure you find x and the measure of angle A. I'm going to give you your worksheet to work on. Then we're going to go to lunch. When you come back, we are going to then do constructions. I'm going to show you on triangles the three main constructions of concurrent points. And if you're really good, you'll be able to balance a triangle on your finger because you'll find the centroid. And if you find the centroid, that's the center of balance, and you'll be able to balance that triangle on your finger. But that is part of our standards also, and you'll have to do some of those on your tests too. Yes.
Can you just go back to question
Sure.
10, please?
Sure. Oh, question 10? There you go. Okay. So you're gonna come back at lunch for the constructions, plus I'll give you 10 points for doing the constructions in class, right? Okay. And then I have your test. There's some people that haven't taken the test, so you can look at it. I will let you take your test as soon as I have everybody done taking the test. So that, I mean, to keep it, but I want to take it back because I don't want them to be out there when I still have people that need to take tests. So this is a mixture of this lesson and yesterday's lesson. Daisy, do you mind if Janae uses your notes to write yesterday's notes?
Let me know.
She borrowed your notes?
Let me know.
She borrowed your notes? So some of that worksheet here was yesterday's lesson. So you may want to take these notes. Do you want to borrow them? Where is everybody today? Like Carly's gone and Sue's gone. Is